Hello class, continuation of our discussion in sequence. Okay, so in order to identify if your sequence is convergent or divergent, we must deal with the limits of this sequence. Okay, if so, here's the following condition. Okay, so the sequence is convergent if the limit of a sub n as n approaches infinity exists and it is finite. Okay, there's a limit. Okay, if there's a limit, the sequence is convergent. So otherwise, if there's no limit or the limit is infinite, the sequence is divergent. Okay, so let's have an example here. Okay, so given that we have a sub n, okay, given that we have a sub n equals 3n plus 4, okay, and we need to evaluate it from 1 up to positive infinity. Okay, so let's try to find the first few terms. Okay, okay, let's find the first few terms, and that is this one, right? If we determine the first few terms, that is this so we have this. Okay, if we identify the first few terms, and then from this, okay, so let's analyze the behavior of our sequence. So we have 7, 10, 13, 16, so on and so forth. Okay, and as you can see, the behavior, right, it is increasing. Okay, it is increasing infinitely. Okay, and the idea here is it is increasing infinitely, and you don't know what is the maximum value, right? So you don't know the limit, so therefore we can say that the limit here is okay, if we're going to get the limit of this, okay, limit of 3n plus 4, okay, as n approaches infinity, so that the answer is infinity. Okay, and since limit does not exist, therefore this series is a divergent. Okay, it is divergent. So next, let's analyze this. So we have another example. So we have a sub n equals 1 over 3 raised to n, and we need to evaluate it, no, from n equals 1 up to infinity. So again, get the limit of this. Okay, limit of 1 over 3n raised to 1 over 3n as n approaches infinity. Okay, so we can do the same process. Okay, get the few limits. Okay, so let me copy this answer. So okay, so if we get the some limits here, or some terms, okay, if we identify the few terms based on our general formula, so we have 1/3, 1 over 9, okay, we have 1/3, 1 over 9, 1 over 27, 1 over 81, and then if you convert it, converting it into decimal, so we have this 0.33, 0.111, 0.37, 0.01. Okay, analyzing the behavior of our sequence, it is decreasing. Okay, decreasing, and it is decreasing. Also, it is bounded below by 0. Why? Because it approaches 0. Okay, so we can say that the minimum value is 0. Okay, and from that idea, since it is bounded below by 0, there's a limit. Okay, and the limit of this, okay, the limit of 1 over 3n as n approaches infinity is equal to 0. Okay, there's a limit. And since there is a limit, therefore, this series, okay, is convergent. Convergent. Okay, so that's how you identify, or one way, okay, one way of identifying if your series, if your sequence if your sequence is a convergent or divergent. Okay, sorry for the term, it should be sequence. Okay, we're dealing with the sequence now. Sequence. Next, I'll show you another way of getting the limit. Okay. Okay, given that we have this example. Okay. So let's evaluate its limit. So we can evaluate its limit by simplifying it or by doing algebraic manipulation. Okay. So we have the limit as n approaches infinity of 3n squared minus 1 over 10 n plus 5 over n squared. So what we can do here is to factor out n squared, both numerator and denominator. So we have n squared times the quantity 3 minus 1 over n all over n squared times the quantity 10 over n plus 5. Okay. Next, simplify. So cancel n squared. Okay. So we have 3 minus 1 over n over 10 over n plus 5. Actually, don't forget the limit. Don't forget to include the limit. Okay, don't forget to include the limit because we haven't doing the limit, evaluating the limit. Okay, so this time we will evaluate its limit. So if we replace all n by infinity, so we have 3 minus 1 over infinity all over 10 over infinity plus 5. Okay, so let's analyze the behavior of this term 1 over infinity. So 1 over infinity, okay, as the value or let's say as this value does, as the value increases or as the n gets bigger, originally that is n, right? So we just replace it by infinity. So as the n gets bigger, okay, it approaches 0. So that's why we have 3 minus 0 here. Okay, all over. So let's analyze the behavior of 10 over infinity. As the n gets bigger, so it is also approaches 0. So we have 0 plus 5. So in short, the answer or the limit here is 3 over 5. Okay. So that's another way on how to evaluate the limit. Okay. Next, okay, another way. let me present you another way of evaluating the limit. Okay. Let me copy this so that okay. Using L'Hopital's rule, okay. So in this L'Hopital's rule, okay, to get the limit, okay, the limit as n approaches infinity of f of x over g of x, okay, given that you have a rational function, okay. So it is equivalent to the limit as limit as n approaches infinity, or sorry, it should be x pala, as x. Okay, the limit as x approaches infinity of the derivative of f of x over the derivative of g of f of x over the derivative of g of x. Okay, so in short, we just simply get the derivative of our numerator and denominator until you get a specific value for the limit. Okay, until you remove the variable. Okay, so anyway, so let's proceed. So the limit as n approaches infinity of this 3n squared minus 1 over 10n plus 5n squared. Okay, so what we can do is apply the L'Hopital's rule. Okay, differentiate the numerator and denominator. So let's differentiate first this one, the numerator. So we have 6n. Okay, next differentiate the denominator. Okay, so we have 10 plus 10n. Okay, next let's try to differentiate it again. Okay, it is continuous. Okay, you can differentiate it continuously as long as you have as long as you obtain the limit. Okay, so let's differentiate the numerator again. So that is 6 over, so differentiate the denominator. So we have 10. Okay, so we have the limit, that is 6 over 10, or simply we have 3 over 5. So this is exactly the same as the answer earlier, which is 3 over 5, right? So let's have a recap. Okay, so okay, I forgot. Since we have limit, okay, here, since we have limit in this example, since we have limit, the this sequence is convergent. Okay, by the way, it is convergent. Okay, so let's have a recap. Okay, so in order to identify if your sequence is a convergent or divergent, you must or you can apply the limit. Okay, you can apply limit in the sequence. Okay, so if there's a limit, the sequence is convergent. Okay, if otherwise, if there's no limit, the sequence is divergent. Okay, next, so you can get the limit of a series of a sequence by analyzing the first few terms of the sequence. Okay, analyzing the sequence, the behavior of that sequence. Next, you can also get the limit by applying by manipulating it algebraically. Okay, okay, and lastly, we can get the limit by using L'Hopital's rule. Okay, differentiating the numerator and denominator. Okay, so from that, after identifying the limit, you can conclude if your series is either a convergent or divergent based on your limit. Okay.